Okay, so what we're covering today is problems that Dr. Saldariaga assigned from sections 1.2, 1.3, and 1.4. So far, we've gone over number 9 and number 10 from section 1.2. So now would be a good time to pause the video and go through number 9 and number 10, and they're worked out on this side. Okay, and the final answer for number 10 is this. Okay, so pause the video, go through that. Okay, now we're going to go through number 17 from section 1.2. We're going to go through number 17 from section 1.2. So I'm going to move this up here and highlight it. So this is an example of cost. So remember, a cost is an application of a linear model. So let's read it. A piano manufacturer has a daily fixed cost of $1,000 and a marginal cost of $1,500 per piano. Find the cost C of X of manufacturing X pianos in one day, and then use your function to answer the following questions. On a given day, what is the cost of manufacturing 3 pianos? B, what is the cost of manufacturing the third piano that day? C, what is the cost of manufacturing the 11th piano that day? D, what is the variable cost? What is the fixed cost? What is the marginal cost? And E, graph C as a function of X. Okay, so we're going to approach answering this problem a little bit differently because I'm going to call for certain rows to do it. Online, you're a part of row 3, okay? Hello? I'll wait for you to respond. Okay, you're a part of row 3 online. So row 3, we have first to find the cost function, C of X, of manufacturing X pianos in one day. So row 3 in class and online, what's C of X? Yes. 1,500x plus 1,000. Very good. Does anyone have questions about that? Or what questions do you have about that? So how were you able to come up with the 1,500 as your M?
Well, it says per piano, so X would be the number of pianos that you're manufacturing.
Good.
And then 1,000 is your fixed cost, which is no matter how many pianos you make, how many pianos.
You got it. Very good. So 1,000 is your fixed cost because it says that's your daily fixed cost, and it says $1,500 per piano, so that's your M. Very good. Okay, so C of X is equal to 1,500x plus 1,000. Row 2. Row 2, let's do part A. On a given day, what is the cost of manufacturing 3 pianos? How do we go about finding that? Yes. So we're finding what? So we use our function that we found. So you substitute in 3. Good. So you said you find C of 3. So what do we do? It'll be equal to what? 5,500. What is our unit here? Dollars. Good. We're talking about money. That's our cost. So that's part A. Good. What questions do you have here? Row 1, you're up. Row 1, part B. What is the cost of manufacturing the third piano that day? Yes.
Wouldn't it still just be 1,500?
Why?
Because the amount per piano doesn't change. How many you make is what's changing.
Say it one more time.
The price per piano doesn't change.
Right. The price per piano doesn't change. So that's going to be $1,500, as you said. Very good. When you put the $1,000 down, do you have to keep putting that down? Yes, no? No, absolutely not. That's your fixed cost. So you're right. This will be $1,500. Okay? Because that is your marginal cost. Okay? C. What is the cost of manufacturing the 11th piano that day? Third row. Yes? It's still $1,500. Good. It's still $1,500. Good. D. D, we have to find out what is the variable cost, what's the fixed cost, and what is the marginal cost. So let's write the variable cost, fixed cost, and the marginal cost. Second row, this is you. What's your variable cost equal to? Yes.
Would that be X?
Would it just be X? Your neighbor's shaking their head no. Well, it's 1,500X. Good. It's 1,500X. So let's pause here for a second and remember variable cost. Variable cost is a function of X. So you are right to think that there has to be an X involved. But whenever you're looking at the variable cost, you want to take M times X. Okay? You want to make sure you take M times X. So that would be 1,500X. What is your fixed cost? Still in row 2. Anybody in row 2? Yes. 1,000. Good. That's 1,000. Still in row 2. What's your marginal cost? Yes. 1,500. And on all of these, good by the way, and on all of these, what's missing? Dollars. You got it. Good. So we need to add dollars in here. We can write that a little better. That looks bad. What questions do you have? Okay. Make sure you're working on math. Some are working on other things. Make sure you're working on math. E says graph C as a function of X. Graph C as a function of X. So in other words, we need to graph this function. So E, we are graphing C of X. We are graphing C of X. So we want to graph this function, 1,500X plus 1,000. Third or first row, what do we do here? How can we go about doing this?
Find your y-intercept.
What's your y-intercept?
1,000.
1,000, good. Now, does this have to be drawn to scale? Not necessarily. So we're just going to do 1,000. Want to put 1,000 there. Or you can put 1,000 whenever your day is 0, right? So let's do this a little bit better. So whenever you have it 0, it's 1,000. Let's say this is 1,000. Okay. And 1, 2, 3, and so on. And then you would have 1,000 go by increments of 1,000 here. So 2,000, 3,000, and so on. So whenever you sketch this, what is it going to look like? Draw it in the air. Very good. I see you drawing it in there. So let's do this. It's going to look like that. Is it going to curve at the end like I made a mistake to do? No, because it's a what? It's linear. So linear is a line. Good. So that's what it's going to look like. Very good. What questions do you have here? Okay. All right. Perfect. So let's keep moving. So here you had to do numbers 2, number 5, number 8, and number 9 here. Did you all have any questions there? What questions do you have about these? So here you had a table of values for a linear function is given, and you had to fill in the missing value and calculate m in each case. That's for 1 through 5. So how would you do number 2? I see some people writing for the first time, so let's do this. I'm going to pause this, and I'm going to give you a couple of minutes to check in with your neighbor. Okay, so I'm going to pause. So let's take a look at number 2, and then I'll give you some time to work on number 5. Okay, so first, what is this missing blank entry in this table? What is that supposed to be? Anyone. You want it? Get it. Ne- -5. Good. -5. Now, we filled in the missing value. Now we have to calculate m. How do we do that? Yes. So how do you find your change in y? So you said use the change in y over the change in x. That's good. That's going to give us m. And I can write it a little bit better. So m is your change in y over your change in x. So go ahead and tell me what we do. The change in y is -2. And what's your change in 1? So what's your slope? -2, because it's -2 over 1. Does everyone agree? Good job. So -2 is our slope, m, and then we have the missing entry is -5. What questions do you have about that? Okay, good. Go ahead and do number 5. Okay, so what do we do for number 5? What is the missing entry? Is that what you found first? Or did you find the slope first? You found the slope first? How did you find the slope here? How did you find the change in y? You're right, it's the change in y over the change in x. Ah, okay. 10 minus 4. And how did you get 2 plus 2? Good. You got it. So this is, say it again, is what? 6 over 4 or 3 over 2. Very good. So that's your slope. Very good. So your slope is 3/2. And how do you find the missing y? Yes. So 10 minus 4 is 6, he said? So 6 divided by 2 is 3. You said you do what? Why are you using 3? What now? Okay. So is it necessary for us to divide it by 2? I'm sorry, what? No. So you're right. 10 minus 4 is 6, 6 over 2 is 3. And you said this was your what? I can't hear you. This one, just the 10 and the 4?
Yeah.
So again, why'd you divide it by 2?
I don't know. I should have just did it the other way.
Okay. What? Okay, so which way does everyone want to use this? How can we go ahead?
So since
Yes.
You just plug it into y equals mx plus b. So take 2 points. So you can do, say 10 and 2. So it's 10 equals 3 halves 2 plus b times 2 plus b.
Say it one more time. 10 equals what?
The slope, so 3 halves times 2 plus b.
Plus b.
You get 5b.
And then that's 10 equals what?
7 equals b.
What's 3 halves? What's
Uh,
3 halves times 2?
3.
3 plus b.
So b equals 7.
So b equals 7. Good. That's how you can find out what this missing entry is here. There are many ways to do it. Your way was okay as well, but you just have to work on the explaining how to get there. Okay? But there are many ways to approach finding that entry. This is a way that you can use knowing what your slope is, choosing one of the points. So here we chose 2 comma 10, and we used that with the slope intercept form and found b equals 7. So then the 7 would go here. Good. What questions do you have here? Okay, good. So b was equal to 7. Number 7. In exercise 7 through 10, first find f of 0 if not supplied, or first find f of 0 if that's not given or supplied, and then find the equation of the given linear function. How would we do this for number 8? Is f of 0 given? What is f of 0? Good. So here f of 0 is equal to 3. We chose that because our first row is x. Our second row is the output, f of x. When x is equal to 0, f of 0 is equal to 3. That's how we chose f of 0 is equal to 3. So make sure that you are okay reading that from the table. And now, since we know that f of 0 is equal to 3, what do we need to find now? Yes, you got it. Very good. Find the slope. Bless you. Find the slope. Take a minute and find the slope. Take a minute and. Okay, tell me how we find m. Yes.
So it's again the change in y over the change in x.
Good.
So I just did like 4 minus 3, which is 1, and then that's over 3 minus 0, so it would be 1/3.
So you did 4 minus 3 over 3 minus 0. So you chose to look at this point and this point. That's fine. That's good. So you said you get what?
1/3.
1/3. So you get your slope is 1/3. Good. Now what?
And then you put that into the equation. So, I mean, you already have what your y-intercept is, which is 3.
Mm-hmm.
So it would be y equals 1/3 x plus 3.
You got it. Good. Y equals 1/3 x plus 3, because whenever we found f of 0, this told us our y-intercept is 3. Very good. Okay, so I think you can do number 9. So now what I want to give you an opportunity to do is ask me questions about anything you may have. Other problems from this section, this is section 1.3. So again, this is section 1.3. All of the problems assigned from 1.3 were numbers 2, 5, 8, 9, 11, bless you, 13, 31, 37, 43, 46, 59, 61, 65, 81, 83, and 87. Were there any problems that you had questions about here? Yes. Number 65? Yes. Were there any other ones? Did you have questions about any of the others? Yes. 65, 87. Any others? Okay, so let's spend time going over 65 and 87. Okay, so let's go through number 65 and number 87. So 65, your instructions here where you had to find a linear expression. You have to find, oh, doesn't like it when I write right there, so you had to find a linear equation whose graph is the straight line with the given properties. Okay, so 65 says we need a straight line that goes through the point 20, negative 3.5, and increasing at a rate of 10 units of y per unit of x. Okay, so how do we go about finding this? Yes, go ahead.
You just do the change in y over change in x again.
Good, so you do the change in y over the change in x to find your m. So your change in y, how do you go about doing that?
Well, that would just be 10.
You're absolutely correct. That's just 10, right? Because it says that it is increasing at a rate of 10 units of y. What's your change in x?
1.
That's just 1. Good. Because it says per unit of x. So that means your change in x is 1, which means your slope is 10 over 1, which is what? 10. Very good. So that's your slope. Now, what do we do? Yes?
Well, we really only need to find our b.
Right.
We can plug in what we have into y equals mx plus b.
Good. So we need to find b. So you said we can plug in what we have into y equals mx plus b to find it. Good. So tell me what we do.
So we have negative 3.5 is equal to our slope, which is 10 times 20 plus b.
Plus b, which means what?
So then we can divide both sides. Well, there's multiple ways that you can do it to find b.
So what should, if we're isolating b, we have negative 3.5. Before we divide, we should multiply these two, right?
Yeah.
So we get, because we probably don't have to divide here,
No.
right? Because you have negative 3.5 is then equal to what? What's 10 times 20? 200. Good. Plus b, and then what do we do to both sides? Subtract 200. Very good. So subtract 200 from both sides, and that will give us b equals what? Very good. Okay, so we have b is negative 203.5, which means what? Because now we need to find our linear equation. So what do we get? Yes, go ahead.
For the equation,
Yes.
we get y equals 10x minus 203.5.
Good. Very good. Very good, all three of you. So you have y equals 10x minus 203.5. Is there anything else for us to do? No, because we did exactly what the question asked us to do. This is what we found. What questions do you have there? Okay, so now let's take a look at number 87. Do you need a couple more seconds to write this down? Online, what questions do you have? You have to talk. Okay, all right, so now let's look at 87. Okay, so for 87, we have an application. Okay, we have an application of the content that we've been learning about linear functions and models. So here it says demand for smartphones. The following table shows worldwide sales of smartphones and their average selling prices in 2012 and 2013. So for the first row, this is our year. We have 2012 and 2013. So the selling price in year 2012 was 385 and the sales in millions was 720. The selling price in 2013 was 335 and the sales was 1010, or yes, the sales in millions was 1010. Okay? A, we have to use the data to obtain a linear demand function for smartphones. And then we have to use our demand equation to predict sales if the price is lowered to 265. That's the first thing we have to do. So I see people writing the information down. So what I'm going to do is give you 2 minutes to work on this with your neighbors. Use the data to obtain a linear demand function and use that demand equation to predict the sales if the price is lowered to $265. So take a couple. So here, instead of y equals mx plus b, you want to use q equals mp plus b. And let me tell you what the variables are. P, so note, P is the price and Q is the demand. Bless you. And Q is the demand. Does that make sense? Bless you. Does that make sense? Okay. So now what you have to do is you still have to go about and you have to find the slope, right? We have to find out the M. We have to be able to fill in the unknowns here, the M and the B specifically, to write an equation or a linear demand function. That's our first goal. So our first goal is to use the data to obtain a linear demand function for smartphones. So here, to find M, let's first write down our points. So for 2012, what the corresponding point, your selling price is 385, and for 2012, but then what's your sales? 720. Very good. So that's the first point. So we're reading the column. So for 2012, our x coordinate is 385, our y coordinate is 720. So now, Joey, tell me what it is for 2013. Good. And 1010. Good. So that's our point there. So now it's set up in terms of 2 points. Now we can use what we normally use, our change in y over our change in x, to find our slope. So m is going to be equal to 1010 minus 720 over 335 minus 385. What is 1010 minus 720? 290. Good. And what is 335 minus 385? Negative 50. Good. We simplified this, and what do we get? You can use your calculators. What do we get one decimal place out? Negative 5.8. Good. We get negative 5.8. What questions do you have here? Okay, so we have our slope. All fine and good. Now what do we need to find? B. We need to find B. So B, how do we do it?
Just pick 2 points, take 1,010 and 335, put it into Y, give them extra Z.
So you're going to use, tell me what's the setup?
1,010 equals your slope, which is negative 5.8, times 335 plus B.
Plus B. Good. And then you got it. So 1,010 equals what's negative 5.8 times 335?
Negative 1,943.
Say it again. Negative 1,000.
943.
Good. Plus B. Then what do we need to do to both sides? Good. So add this to both sides. And then we get B equals what?
2,953.
Good. So B equals 2,953, which means whenever we have to find our linear demand function, Q, we have all of our information. Hence, we can say Q is what?
Negative 5.8
Is it X?
or
B. You said B?
P,
P. Good. Times your price plus 2,953. You got it. Good. So hence, the demand equation is Q equals negative 5.8P plus 2,953. So we found this part. Now we have to use our demand equation to predict the sales if the price is lowered to 265, which means we need to find what? Q when what? You got it. When P is equal to 265. So go ahead and take a minute and do that. Go ahead and take a minute and do that. And then check in with your neighbors to make sure your neighbors have it too. Okay, so tell me what you're getting. So you said to substitute in, so now we are finding Q of, as you said, we're substituting in 265 for P. That's equal to negative 5.8 times 265 plus 2,953. And what do you get here? Yes. 1,416. Good. What? What's your unit? Can't hear you. Q? No.
Sales.
What are we talking about? Million what?
Sales.
So we sold 1,000, or we have 1,416 million what? Phones. Good. Phones. Good. Okay. And then, so this is part A. All of that is part A. So we're good there. And then B, part B here, we have to fill in the blanks. For every blank increase in price, sales of smartphones decrease by blank units. Okay? So for every what?
We just use a slope. It's every like dollar increase.
So for every good, so for every dollar, it's the first blank increase in price, Sales of smartphones decreased by what? 5.8 what? Good. 5.8 million. That's the second blank. Units. What questions do you have? Okay, so we didn't get to the problems from section 1.4. Make sure you go through those, and if you have questions about any of the linear regression, make sure to come to class prepared with those questions next Monday. Okay, have a wonderful weekend. Well, no. You won't be here on Monday, right? Because there are no classes on Monday. So make sure if you have any questions to email Dr. Saldariaga. Okay, have a good one.
Thank you.
Thank you.